Let's look at let's comment on some of those sample quiz questions. And here, our task is to go through the main technique and the concept in about the uh, vector value function and the path, the velocity and the tangent, unit tangent, unit normal, and the arc length function, and the actual arc length calculation, and the curvature, and those concepts. And also, there's equation of tangent line for sure, right? Um, anyway, so here, let's look at the one that people are usually kind of neglect in the review, which is the arc length function. So the arc length function is very important because that give us a tool to compute the arc length, and actually we can use it to do a lot of calculation, especially in the future aligned integration. All right, so here for this curve or path, we need to write down the arc length function, and here I gave the general formula for that. The most important thing is that we need to set up this integral about a parameter t, and the integrand has to be the length of the velocity vector or the length of tangent vector along the path. So we need to first get the r prime t or r prime u, and luckily I think I computed somewhere. Oh, here in the question above, we computed the tangent vector. So we just need to compute the length of it. Well, it is already computed also. So we put this e to the t times square root 2 into the integrand here. And use the integration of rho u. So it becomes e to the u times square root 2. And then we're finding the antiderivative of this, and then you evaluate at the two ends of the integral. So this is what we have. All right, so with this arc length function, you can prescribe the t value and compute the actual length along this curve, starting obviously from this one. Okay, starting at this parameter equals 0 and stop at any arbitrary parameter. And here, I think in this question, we need to find the arc length along the path between 0 and 1 for t. So we need to calculate s of 1. This is the e minus 1. E minus 1. So we got this. All right, so that's relatively easy if you know the formula. And the next important topic is the so-called curvature. And a curvature for this, right, could be computed in two different ways, because this is not the arc length parameterization for sure, right? So this is the first way. You got to compute the unit tangent first, and take the derivative unit tangent, and then compute the length of it, and then divide it by the length of the velocity vector or the tangent vector, which are the same thing. So we did provide the calculation here, and then those are the calculation we have for this question 5. And I did notice that there might be some challenging part for this question 6, so we can just ignore it for this quiz. Okay, so those are the calculation we should be really get familiar with, and so that we can prepare for the quiz on Friday. Oh, and the first one. The first one is about a problem projectile, right? So for any of the projectile problem, we assume the only force applied is the gravity force. So the acceleration vector is this, and here this g is the gravitational constant, gravity constant, right? So here we assume it to be 10. We got the vector a, acceleration, which is the second derivative of the path r. And we integrate it once. So we get r of t, r prime of t. All right. And we integrate this acceleration to get r prime t. So get the constant ABC, little ABC, and we got this little ABC with the c minus g t. G is 10, so we got this. This is the velocity vector. Or at t equals 0, we got at t equals 0, we got a v of 0. So we can determine as a little a, b, c constant, which are determined by those three. Okay, and then we integrated this velocity vector once. So we get this actual capital A, B, C as constants. And when we set this to be 0, when we set t to be 0 for this path, we get the initial position. Okay, so for the big A, B, C, those are the value to determine them. Okay, so this is little ABC. Okay, and then we can figure out this path explicitly. And then we can answer the question, how long does it take for the projectile to land? And what does it mean? That means you need to figure out the t value such that this is 0. Okay, and at that particular point of t, you can figure out what is x and the long value. So this essentially gives us everything we need. And then for everything else, I think pretty much we know how to work out in detail if you go through the video discussion and also carefully. All right, so let's just stop here.